Good morning, dear students, and welcome to Vista's e-learning and online educational platform. My name is Denzil, your physics tutor for class 11. Let's get started with today's session. Today we discuss one of the most important part of this chapter, which is solving problems in mechanics. This is a session 9 of the chapter Laws of Motion. So now what we're going to do in this session is put to use all the concepts that we have learned in this chapter of laws of motion. So let's begin with a question and then try to understand how to solve a given question with the following steps. So steps to solve a problem where multiple forces are acting on the object. So here's a quick question. A mass of 4 kg rests on a horizontal plane. The plane is gradually inclined until at an angle of theta equals to 15 degrees with the horizontal. The mass just begins to slide. What is the coefficient of static friction between the block and the surface? This problem here looks more of a realistic problem, where you have a block that is placed on an inclined surface. The angle of inclination of that surface is already given, which is 15 degrees. Also, the mass of the block is given 4 kgs. What we need to determine here is the coefficient of static friction. Now, in order to solve this problem, we first need to understand the following question with the help of a diagram. So let's illustrate this question with a diagram. Now to do that, we follow certain steps. So step number 1, draw a diagram showing systematically the various parts of an assembly of bodies, the links, supports, etc. So in this case, we only have an inclined surface and a mass of 4 kg that is placed on the surface. So we have okay, let's select an ink color red. Here we have an inclined plane or inclined surface whose angle theta equals to 15 degrees. Okay, and also we have a block whose mass is 4 kg. See, a very simple diagram. Now similarly, you may have other diagrams with different supports and links. An example is when it comes to drawing water from a well. So you have a well and you try to draw the water. The system that is used there is a pulley system. A pulley system is where you have a fixed axis of rotation and a rope that goes around those fixed axis of rotation, and then you try to draw the water. So in a figure, it looks more like this. So you have a pulley that is here, and you have a block or some mass or a load which has a certain mass. So this is a diagram of a pulley system where you have a pulley that is fixed here and a mass M is lifted up using this pulley system. And pulley, as we know, is nothing but a simple machine. So now that we have finished step 1, let's look into step 2. What do we do next? Choose a convenient part of the assembly as one system. Now, why are we doing this? Why do we have to choose a convenient part of the assembly? What we're trying to determine here are what are the multiple forces acting on that block of mass M equals to 4 kg. So this block, which is resting on an inclined plane whose mass is 4 kg, what are the various forces acting on the block? To identify what are the other forces acting on the block, we have to choose a system. And the system we're trying to consider is this block. Similarly, in case of a pulley system, There are various forces acting on this load. So the system that you have to consider is the load where various forces are acting on the system. Now that we have selected a part of the assembly as one system, like this block here, or it could be load in this following case. Next, what do? Step number 3, draw a separate diagram which shows this system and all the forces on the system by the remaining part of the assembly. Separate diagram which shows the system and all the forces. So here you try to show all the forces that are acting on that system. Now remember, the system that we considered here is the block. So what are the various forces acting on the block? So what happened? It is that. Okay. We have an inclined surface and I have my block, which is this. Very good. So what are the various forces? One is this weight, a force which is acting downwards towards the earth, called the weight, which is given by where weight equals to mass times the acceleration due to gravity. Okay, so this is one of the forces. Now, once this block is placed on that plane, this block will start sliding down the surface. As it's sliding down the surface, there is a frictional force acting in the opposite direction. Yes, so there's a frictional force acting along the opposite direction. So let's put that as F of S to show a static friction that is acting along the opposite direction. Now, to this weight, two different components can be constructed by an angle which is theta, the same angle at which the surface is inclined at. So if this surface is inclined at an angle theta, so one of the component can be identified. So this is one of the component which can be stated as mg cos theta. Okay, so we have one component acting along this direction. So let me draw that proper. Yep. Select blue color. All right. Yeah. So this will be mg cos theta. All right. Now also you can identify another component which is along this direction, which is mg sin theta. See, we've identified two different components for a given weight. One component is mg cos theta and the other component is mg sin theta. Mg sin theta and F of S, which is frictional static friction, the opposite in direction to each other. Okay, so now we have identified what are the multiple forces acting on this block. Next, this type of a diagram, the one which I've now just constructed, so let me move this side. A diagram of this type is known as a free body diagram. So once you consider a system, once you have chosen the system and you have identified what are the various forces acting on that system, then the type of a diagram is called a free body diagram. Important note, do not include the forces on the environment by the system. Okay, so these type of forces must be avoided. Now, step number 3 is complete. Let's move on to step number 4. In a free body diagram, include the information about forces and the magnitude and direction, which we just did. So I'm going to copy paste it here. All right, so once more, just copy paste there. Oh, and the block, and then you have various forces that are acting. This is theta, this is mg cos theta, mg, and mg sine theta, and then you have f of s. See, we've already mentioned what are the information about the forces. See, the forces have been mentioned, which are the various forces. Magnitudes, the length of the vector determines the magnitude, which is done, and also directions. We have mentioned the direction by those arrows that are pointing along certain path or points. So good. So now we are set with step number 4. Step number 4 also done. We're good to go. Step number 5, employs Newton's third law if necessary. Where can we use Newton's third law in this following case? Witness this. Since you have a force that is acting in a downward direction, you have this opposing force or frictional force. Newton's third law satisfies. No problem with the sliding. The motion part, there is no problem with Newton's third law. Now, here, observe when it comes to the weight. The point where it is in contact with the surface, where mg cos theta is the force that is acting where it is contact with the surface. Since there's a weight that is acting on the surface, then there will be a normal force acting upward. The same reason why when you place a book on the table, that book has a certain weight to it. But you don't notice the table breaking. Why don't you notice the table breaking as you place a book? Is because the table provides an opposing force which is called a normal force perpendicular to the object or to the surface itself. So similarly here, you have a force which is the weight by Newton's third law. So let me put that here. You have this block. One force is acting along downward direction, which is mg cos theta. This is the surface. Then what happens is that there's an opposing force which is acting in an upward direction. This is given by normal n. Okay. All right. So now that we have this set of information, next what we do, we will solve the given problem. First, the diagram, free body diagram, and then we solve the given problem. So let's put them all together. Whatever steps that we have learned, we'll put them all together in one, and then we will solve. So I have equals to 15 degree, a block which rests on an inclined surface. That's hardly even 15 degree. It looks more of a 65 degree. I'll change that. Not to worry. I'll change that. I understand the inclination is more than what we need. All right. So this roughly we call 15 degree. Okay. All right. Now for the forces. Okay. So this will be mg cos theta, mg sine theta, fs n. All right. Now let's put them together. One, you see mg sine theta, magnitude of mg sine theta and fs are equals. So I can write that mg sine theta is equals to Fs. Similarly, we can also mention that mg cos theta, which is equals to the normal n, downward and upward. Okay. And what we have learnt in friction is that coefficient of static friction Fs is given by mu times n, mu s. So it's actually less than or equals to mu s times n. So this is a coefficient of static friction. So in place of Fs, I will substitute mu s n. And these two equations, I will divide one another, okay? By dividing the above two equation, by dividing above equations, I get sine theta by cos theta. What happened to mg and mg? That they cancel. Okay, so what you're left with is sine theta by cos theta equals to mu s n by n, where n and n gets cancelled, and what you're left with is this. Choose a different color. Is this tan theta is equals to mu s. What we need to determine is the coefficient of static friction. Yes, look. What is the coefficient of static friction between the block and the surface? Well, coefficient of static friction can be determined by taking tan of theta. Do we know the angle theta? Yes, we do. So, this implies tan 15 degrees is equals to mu s. This will give you the solution for coefficient of static friction. All right. So I hope you've understood how to construct a free body diagram, a very important part of mechanics in order to identify the multiple forces that are acting on the block. By identifying what are the multiple forces acting on the block, you can conduct further studies in order to determine what is the net force acting on the block or what are the physical quantities that you can acquire from that following information. So that is all I have for today. So I'll see you in the next session. In the next session, we shall begin with a new chapter. So I will see you all. Until then, take care and have a nice day. Bye-bye.